Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's Linode, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Are you bored with writing scripts to move data into SaaS tools like Salesforce, Marketo, or Facebook ads? High Touch is the easiest way to sync data into the platforms that your business teams rely on. The data you're looking for is already in your data warehouse and BI tools. Connect your warehouse to High Touch, paste a SQL query, and use their visual mapper to specify how data should appear in your SaaS systems. No more scripts, just SQL. Supercharge your business teams with customer data using High Touch for reverse ETL today. Get started for free at dataengineeringpodcast.com/hightouch. Your host is Tobias Macey, and today I'm interviewing Eric Sammer about Decodable, a platform for simplifying the work of building real-time data pipelines. So, Eric, can you start by introducing yourself?
Yeah, absolutely. My name is Eric Sammer. I'm the CEO and the founder here at Decodable. And like you said, our job is to make stream processing accessible to mere mortals. What we like to joke about, no longer the realm of PhDs and PhD dropouts. That's sort of where we want to be able to help people.
Absolutely. And do you remember how you first got involved in data management?
Yeah, like it was yesterday. In fact, I originally wound up in a lot of ad tech out of New York City, which is where I'm originally from, and built a lot of internal systems for ad targeting and ad serving and campaign management and those kinds of things. Eventually, over, sometime around 2009 or 2010, I got connected to the founding team at Cloudera. And that's sort of where I made the flip from building internal systems to being more sort of on the, the evil vendor side of the equation and sort of building enterprise software for other people. Sort of ever since then, like late 2009, early 2010, I've mostly been involved in open source data infrastructure, everything from, the Hadoop world, to sort of nowadays probably, more Kafka, Flink, Spark, that sort of universe of technologies, and have been working with that stuff ever since.
And that brings us to what you're building at Decodable. I'm wondering if you can describe a bit about what it is that you're focusing on there and why it is that you decided to spend your time and energy on simplifying the work of interacting with and building platforms on top of streaming architecture.
Yeah, absolutely. It really came from the last, 10, 12 years or so, watching people build this sort of first generation of what I think, we wound up calling like the big data ecosystem. And initially it was really focused on analytical workloads and like the data warehouse, and sort of growing and scaling that, was sort of popularized, at least in the open source world, with things like Hadoop and all that other kind of stuff. But increasingly, as that world sort of worked itself out, what we saw was like the advent of, of Kafka, and like this renewed interest on, today what we call probably, real-time data engineering or stream processing and that universe, but historically has been messaging and event-driven architectures and, dare I say, service-oriented architectures that we would have called it, in sort of the mid-2000s or so. It's not strictly about just moving data around, but it's actually, caused this resurgence in building these like reactive or sort of event-driven applications. And I think it's sort of interesting to see the adoption of Kafka in the world, and what that has done, especially with the, birth of things like Kubernetes and microservices. So now you have sort of this decentralized way of building applications, which is all message passing and things like that. And it is maybe not easy, but much easier to stand up and build individual microservices that are sort of responding, to API calls and event data. So the two things that we saw were, one, as people started to do that, all of a sudden, the sort of system of record moved to the stream. It really became the event stream that was coming out of applications, whether that was click stream data, whether that was explicitly instrumented events in sort of various kinds of applications. And that data was kind of teeing off into two directions. One was it became the ingest stream into the analytical systems. These days that's Snowflake, BigQuery, Redshift, Athena, S3, all these other kinds of things. But also feeding a bunch of real-time microservices, ML pipelines for scoring and enrichment and all these other kinds of things. The short answer is that right now it is kind of where the big data ecosystem was in 2010, or the relational database ecosystem in the 80s, where it's really low level, right? We're asking engineers to deal with messaging guarantees and distributed checkpointing systems, job recovery semantics. And most engineers either don't want to or just don't have the time to deal with that level of complexity. They kind of want something that is simpler and kind of just does what it's supposed to do on the tin. And so, while lots of people are building this stuff from Kafka and Flink and Spark Streaming and all these other kinds of systems, which are all great systems, they're really low level building blocks. And so we said, well, can we take advantage of what has happened in the open source ecosystem, but then add back the higher level data engineering challenges, like making schema management possible, making reprocessing of data possible, and really up-leveling this away from dealing with clusters and Java class loaders and messaging guarantees, and toward SQL pipelines. Not that we love SQL, but everybody knows it, and enable people to sort of quickly build real-time data pipelines the way they do in the batch world, so that we get away from this idea that streaming is just way too hard for people or isn't worth it. Does that make sense?
Yeah, it makes absolute sense. And I think your mention of SQL is interesting as well, because some people might love it. A lot of people don't, but it's, the best tool we have for the job because everybody knows it. It's one of the it has become the entrenched player in the space. And so you have to use it in order to be able to take advantage of it, because the ecosystem has gained so much momentum, similar to where Kubernetes is starting to go in the infrastructure space. I think it's interesting too that I remember, when I was first starting this show, maybe about 4 years ago now, there was a lot of conversation about the idea of streaming SQL and adding different semantics to SQL to be able to do continuous evaluation of queries. And then that subsided for a while. And now SQL on top of streaming engines has gained a sort of a new focus, but without necessarily focusing on that continual evaluation of the query with things like Flink SQL and Spark SQL and KSQL DB and all of these different products.
Right. I mean, I'm with you 100%. I mean, look, like I said, I think SQL is deceptively simple or deceptively complicated, depending on how you look at it. And when people say they know it, what they really mean is that they know sort of the bare sort of minimum of that. I mean, I have been dealing with it for a very long time. I have lots of gray hair over it. And every time I have to write a window function, I still have to look up the syntax over certain things, right? So there's just endless complexity there. What I will say though is the time to value, and with my vendor hat on just for a second, the fact that somebody can do a hello world ETL job, in 30 seconds or less, or your money back, kind of situation, is high value, not just for us because, it sort of shows well, but also for people who, let's face it, 80% of the data engineering jobs that we write are stripping PII data, filtering data, routing data to the right place. It's not necessarily launching rockets into space. There's lots of complex business logic that goes on it, right? I'm not trying to badmouth it. I'm just saying that we over-rotate on these hyper interesting and sort of theoretically, exciting pieces of stream processing semantics, when in fact 80% of the jobs are just I need to rename a field and destructure or normalize a nested JSON blob. I think we've, in a lot of ways, as engineers are wont to do, we've overcomplicated things, for sure. And so our perspective is, look, we don't think that we replace Spark or Flink or any of these things. If you need to build really complex online ML infrastructure, you need sort of low level access and that level of API sophistication. That said, like I said, 80% of the time, like prepping the data to get into one of those systems or, POCing, a new data product or product recommendation system or something like that, it actually doesn't have any aggregations. It often doesn't have joins, right? It's often just the dumbest thing in the world. And what you want is for it to just work. And so we've taken a very pragmatic view here, which is like, yes, we will go deal with like all the nuances of, how to make the engine sort of do the right thing. But for the most part, people just don't bump into that stuff unless they're doing the really crazy stuff. And there it's about being open and speaking de facto open source standards and integrating with sort of all the tools and technologies that you already use today so that you don't have to like re-platform and that we don't have to be sort of the hammer for every nail, if that makes sense.
And so in terms of the focus of what you're building at Decodable, who are the main group of users that you're focusing on, and how has that persona informed the prioritization of the features that you're building at launch?
Yeah, no, that's a great question. So the two groups of people we see are application developers and data engineers. They sort of map to the two use cases that we see. One where Decodable is sort of a means to collect a whole bunch of data and pump it into various analytical systems, like the snowflakes and the big queries and like all those kinds of things. And there we're sort of like a very, very real-time data ingest system that has like all the stuff that you would expect, with SQL and connectivity and that kind of stuff. The application developers tend to be working more around, like I said, building these event-driven architectures or reactive architectures, whatever the buzzword is du jour on this stuff, where for security, for instance, it might be watching all failed logins and looking for dictionary attacks or looking for, sources of, source CIDR blocks where they're coming from, and then like automatically inserting firewall rules to like shut down, API access in a web application firewall, like a WAF or something like that from a particular CIDR block. It could be product recommendation systems. It could be enrichment systems. It could simply be real-time user-facing analytics, where you're using a social network and they're recommending content, and stuff like that to you. So those are the kinds of systems that we see for application developers. And in terms of like what that does for us in terms of priority is like one thing's for sure. Developers, we're not as concerned with sort of the business analyst kind of persona. We are more concerned with, data engineers want to store pipeline definitions and, those kinds of things in Git and manage it through GitHub or GitLab or something like that, and deploy pipelines as part of CI/CD processes and stuff like that. So we've designed the system around, at least right now, I think we will in the future, but right now we don't even have a UI. Our two sort of things that we give people are a REST API to sort of like dynamically sort of create pipelines and activate them, or a command line tool that is, similar and sort of accessible to people who know things like DBT, where they're used to working a particular way. And we want to make sure that we're not sort of asking people to relearn, how to build campfires or something like that. I think, as we do more around pipeline observability, things like data quality and malformed data handling and sort of visualization of performance characteristics of pipelines, there we get into going like, okay, it makes sense to sort of have a UI to allow people there. But we actually specifically didn't start with drag and drop pipeline builders because every engineer in the world goes like, well, it's not how I work, And I think, like I said before, we're sort of really practical around this. We made sure that we can knock those data prep and sort of ETL style use cases out of the park. There are other vendors and open source projects working on like really fancy real-time analytics out to like the dashboard and stuff like that. I think that stuff's really exciting. I think we're natural sort of like feeders of those systems. But our sweet spot is really around, I need to prep data, I need to clean it. It's data janitor work, which I think is underserved. And there, the main features are when you say activate pipeline, it just works. When you submit a chunk of SQL to us, we are going to ensure that you're not referencing columns and fields that don't exist. We're going to tell you what the quality of the data looks like. We're going to make, the actual process of deployment and sort of previewing what that pipeline does really easy. So it's built for people like you and me who sort of have to build these pipelines on a daily basis.
In terms of the complexities that crop up when you're dealing with these different streaming systems, you've touched on a few as far as like the exactly once or at least once or at most once semantics and, dealing with back pressure and what does that even mean and how do I need to deal with that and the systems that are feeding into the streaming system and all of the sort of distributed systems complexities that come up with it. I'm wondering what are some of the main pain points that engineers run up against when they're trying to build on top of streaming architectures and some of the reasons that they might throw their hands up and give up or, some of the workarounds and wasted engineering cycles that they've had to spend being able to overcome some of those challenges.
The complexity is not in actually building the pipelines, right? All of these open source projects, everything from K-Streams to Flink to Spark, all have like reasonably intuitive APIs. You're sort of arguing the last 10% of complexity there. To your question, the complexity comes in from, as it always does, the operational characteristics. How do I make schema changes that are safe? How do I deal with, actual like data quality issues? And in streaming systems, it is more complicated than batch systems because a single bad record will basically shut down a pipeline to maintain ordering guarantees and state, depending on sort of like how the pipeline works, whether or not there needs to be state and have things partitioned a certain way, which, forces us to establish ordering guarantees and all these other kinds of things. You bump into quality issues, you bump into messaging semantics. If I had $1 for every time I went through the at least once and most once, exactly once discussion and every time Twitter erupts into a debate about whether or not exactly once can even be a thing and all these other kinds of things. So I think people underappreciate the complexity of job failure semantics and recovery. I actually believe that people underestimate the accuracy of their batch jobs. A lot of people talk about time in streaming is super complicated because of event time versus processing time. But if you zoom out, that problem exists in the batch world. The only thing is that you're crossing your fingers that your processing lag sort of catches all the events. But whenever I have dug into someone's batch infrastructure, you find just as many sort of time problems. So I don't know that that's necessarily exclusive to streaming, but it definitely comes to the fore. People are sort of used to thinking about it, talking about it. State management, back pressure, and then you get into any of the individual sort of systems that are popular around this, and tweaking and tuning those things is super complicated. I, some number of years ago, wrote a book on Hadoop operations, and 90% of my job there was documenting all the configuration parameters. And if you look at, I won't name names, but if you look at any of these systems, they all have a couple hundred parameters that are really, really complicated, including things like perf tuning RocksDB databases that are used for state management and stuff like that. No shade on those systems, are good systems, but it's complicated. And, I would argue with hindsight now, back in 2010, it wasn't that people wanted a distributed file system in MapReduce. They wanted a data warehouse. And when you look at streaming systems today, I have a feeling that we're going to be thinking about it the same way. People don't want a stream processing engine. They want a data engineering platform for real-time data. And, again, that's me with my vendor hat on. But I think all of that complexity comes to the fore. We love it. That's what we spend our lives on, working on. And we're super excited about checkpointing algorithms and, consistency. But, our hope is that most engineers don't have to deal with that if they don't really need to deal with that.
And continuing on the sort of distributed systems concepts and some of the design optimizations and some of the engineering effort that's required, but often overlooked or skipped because of time constraints, how do these different elements of distributed systems and streaming systems in particular start to bubble up when people are trying to build pipelines at a higher level to just get the business needs done. Talking again about back pressure, we talked about semantics. Isolation levels is another thing that people will talk about ad infinitum for people who are deep into the space. Is it, read after write consistency? Is it eventually consistent? What are the delivery time and latency guarantees? What is your, P99 tail latencies for message delivery end to end? So
yeah, I think all of those things, yes, is the short answer. I think, the stream processing engine, and probably inclusive of the modern scale out messaging systems like Kafka as well, are really just the sort of almost the purest example of a distributed system where they're just a bunch of processors, performing RPC between one another. And we're sort of arguing the correctness of the operations that they're performing. Whenever you have two machines, you have all the problems around message passing, from the distributed systems literature and FLP and, uncertainty principles and all these other kinds of things. There are people much smarter than me who have explored the universe of why those things are hard. They look like database systems, stateful stream processing systems and messaging systems. So you have all the challenges around durability and what does it mean to actually write something to disk? And you get into whether or not fsync actually does what you think it does, and kernels, and IO subsystems. And then you throw in the complexity of the cloud where storage, is an even thicker stack than it ever was, with sort of object stores and ephemeral disk and attached disk and all these other kinds of things. And, you have a soup of really complex theoretical challenges to solve. I think there have been some really great papers in this space that we pay a lot of attention to. The Google Cloud Dataflow team has put out some really, interesting papers in this space. Everything from, the mill wheel paper to, and I would even say the database literature, Dremel papers and all these other kinds of things that overlap the space. Obviously, UC Berkeley has done a lot of research here. And like I said, I think that, you look at Spark, you look at Flink, you look at GCP Cloud Dataflow, and things like Timely Dataflow, what the Materialize guys are doing. That's really exciting stuff that gets into the nuts and bolts of this. But that is venturing into a land where, you read all those papers and if you're smart enough to internalize it, which I'm not sure that I am, as you read it, at the end of it, you put the paper down and you kind of go how do computers even work? Right? What are we even doing here? And you're not sure that anything works. And so then you have to start trimming down to practical terms and removing, adding back real world constraints. And so I think finding the right set of constraints to add back to make that system practical is where things get super complicated, and where you can make good trade-offs and where you can make bad trade-offs. That's a painful answer. It's probably not even a good answer, but
no, that's a great answer. And to your point of, digging through these papers and how do any of these things ever work is about the point where you either double down and dig deeper into it, or you go live on a remote mountaintop away from any technology and you never look at a screen again.
I think we all know what the right answer to that is. That said, prior to choosing that answer, we'll all be here trying to solve these problems.
And then in terms of what you're building at Decodable, I'm wondering if you can talk through some of the architecture that you've settled on for being able to paper over some of these complexities and provide a robust and understandable API to end users while still being able to actually, I'm not going to say guarantee any of these capabilities because, guarantees in computer systems are, worth about as much as the paper they're written on. But, at least do best effort of being able to, maintain the uptime and correctness of these systems that you're exposing to the engineers who are relying on them.
There's a couple of different aspects to this that I think are particularly interesting. One is, what's the conceptual model that you expose to people? So we talk about pipelines. I am not convinced, or at least I wasn't convinced, obviously, we get this right at Decodable, but the relationship between connecting to external data infrastructure, the streams that represent like the durable buffer of data, which is these days almost exclusively backed by messaging systems. It certainly is at Decodable. And then the pipelines, which are sort of the active processing component. I think that there's a lot of systems that get the boundary of like, what is a connection? What is a stream? What is a pipeline? Or sort of blur those things. Because of our audience, being engineers more than sort of business analysts, we can actually make those relationships very explicit and sort of push the complexity to the part that makes the most sense. So for instance, in Decodable, pipelines only operate on streams. They get one or more streams as input. They output one stream. Multiple inputs can be unions and joins and those kinds of things. And then connections bridge streams to the outside world. And so the complexity of where we touch an external system versus where we are operating internally, that boundary and getting that right actually reduces failures. It actually allows you to better support the messaging guarantees, again, to get back into that discussion, like actually get that right. And so we settled on this connection, stream, pipeline sort of relationship. That's served us really well for a variety of reasons. Like I said, the pipelines themselves are singular SQL statements, right? So we allow you to stack pipelines against each other, and create effectively a bigger DAG, directed acyclic graph. But all of them are attached via streams. And so like you understand very clearly sort of like how things break down in the unit of deployment, which makes versioning much easier, which makes schema changes very, much easier. I won't say very easy. It makes them easier, so on and so forth. I think the other thing, now sort of more about the architecture and the philosophy of the architecture is that there's two camps of thinking on this. And I don't know that we've been explicit about this. One is the centralized camp. All data flows to one place. You do all your stuff to it. And like that is consistent with the traditional data warehousing world. The other case is the distributed case, is that like life is complex, it's messy, and more aligns with like the microservices world, where you kind of go, the best place for someone to build and maintain a pipeline is the person who owns the source of the data and create curated streams for the people who receive that data or make that self-service, right? We could sort of talk about that. We view especially where we sit in the architecture, as being decentralized. And so we purposely separated Decodable into a control plane, which is where you submit pipelines and you see lineage and like all the monitoring and observability of those pipelines. And then the data planes, which are distributed. So you would have a data plane, for instance, in each cloud region of each cloud provider, and maybe even on-prem, if you have that kind of architecture. This matches what the software-defined networking people have figured out like some number of years ago, which is that switches and routers are wherever they are, but what you really want to be centralized is the control and management and observability. And that the control traffic is not in the hot path of the data traffic. And so we've designed Decodable around the separation of control plane that is centralized and distributed data plane, which I think gives us quite a bit of an advantage around how you manage these complex systems. Any company sort of bigger than a breadbox has GDPR compliance and data sovereignty challenges, and this data can't leave that region and so on and so forth. And so we believe that this actually mirrors both the modern enterprise, kind of company, but also jives with what people are starting to talk about with like data meshes. Again, just to throw another buzzword onto the pile, right? Like, which I actually think does make a lot of sense. It does for data what microservices and REST APIs did for behavior or compute. So I think that there's something worth looking at there. Under the hood, Decodable is built on all the same things that people are building on today. So internally, we are very heavy users of, currently Apache Kafka. We have a deep investment in Apache Flink. We believe that, of all the stuff that's out there, Flink's trade-offs between, performance and correctness and scale and, especially like the community around Flink has just sort of had, I think, a really good eye to how these systems should work. And I'm biased. I've had prior experience with Flink now for a number of years where I've seen it in some really, really tough workloads and do reasonably well. So I have sort of high confidence in Flink and the Flink community. So we're heavy users of Flink. We have to, do some stuff to it to to be able to handle, some of the simplification that we've been talking about. But I mean, there's certainly more to it. Happy to answer other questions, but that's sort of like the high level tidbit on Decodable on the inside.
Yeah, definitely a few things to dig into. And one of the things that I think is interesting is you mentioned that as far as the pipeline processing, you're able to combine multiple streams into one output stream, but you explicitly did not say that you're able to take one input stream and split it into multiple output streams. I'm wondering if that was on purpose or if that's something that you intend to be able to explore for being able to do sort of fan out topologies, or if it's something that, if you want to do that, then you need to, jump to a different level of the sort of API abstraction.
Yeah, no, absolutely. I mean, so to be clear, you can accomplish the same architecture by having two pipelines that filter the data in different ways or do whatever they need to do that consume from the same sources and then output to different destinations. So that's how we would accomplish like the fan out kind of routing or distribution kind of architecture. But we specifically did it that way rather than having one pipeline that outputs to multiple streams because one, SQL doesn't really do the latter, right? Select statements have effectively one relation as its output. And so one, we found that the community of people here, this actually jived with sort of their natural way of thinking. If I want a different output, I have a different query. And for us, that's like a different pipeline because a query is a pipeline. And so one, it sort of matches the mental model of people and you don't have to like untrain them from that way of thinking. But two, you start to think about the messaging guarantees of outputting to multiple pipelines. You get into these like weird failure cases where you can output to A but not to B, and then you fail and the power goes out, and now you have a duplicate. Like life just gets super complicated in that one case. Whereas on the consuming side, we do have things like offsets and sort of like all the stuff that Kafka I think has probably popularized in that way of working. And so it's easier to get the correctness, the expected correctness for the user's definition of correctness. It's easier to hit that sweet spot for them without making them think too hard about all of the ways in which it can go wrong. And so the atomicity of the failure to them can feel like the pipeline versus a partial failure of a fan out pipeline. And so we recognize that means that in order to do fan out to like 100 things, maybe you actually have to build 100 pipelines. That becomes harder, but the reasoning about the system becomes substantially easier. And we found that makes sense both, like I said, to get the system right and also sort of, banks on pre-existing knowledge. But we found that people sort of like mostly get that, especially if they're coming from the batch world where they're sort of like dealing with like, SQL queries and Snowflake or BigQuery or Teradata or something like that.
Another thing that you briefly alluded to earlier in the conversation is the idea of being able to do enforcement of elements within the schema in the processing and the definition of the pipeline. And I'm wondering if you can dig into some of the sort of schema metadata management, the introspection of the input messages to understand what are the elements that are contained within them so that you're not trying to select a value that doesn't exist in that nested JSON object, or if it's supposed to exist, identify that, sort of at what point do you understand where that is, and sort of the enforcement of schema within the overall propagation of the pipelines.
So within the engine itself, within the stream processing engine, you're effectively in the SQL world. And so everything does have a type. You do have these open types like arrays and maps and those kinds of things. And to extract something out of a map, we sort of like can force you to say like, hey, like that key may not exist. And so therefore you need to use this function, which takes a default value or something like that. So there it's about providing the guidance through the right functions that you provide to people, when they build the pipeline, and the right patterns. The place where it becomes really complicated is where you touch the connectors, because, just to give an example, our Kafka connector, it's funny because like Kafka is like, a good example of this. The actual general purpose Kafka schema is, and the only thing that's guaranteed to you is, key, value, partition ID, offset, and maybe timestamp, depending on sort of like whether, that's event time or processing time as sort of inserted into the queue. And then there's sort of like these sub schemas that exist within the value and the key of the payload. And that's where schema registries and like all these other kinds of crazy things come into play. Our perspective is that dichotomy between like the user defined schema and the actual connector schema is like super complicated. Nobody wants to deal with it. And so what we've done is that connectors are sort of always going to output a well-known schema. And by schema, I don't include format, like Avro versus JSON versus protobuf. So I'm talking just like the semantic structure of, fields and their types and things like that. The connector can define that. And if it receives anything, and I say the connector, I mean the user who configures the connector says, this is what should come out of this, what should come out of the value. If anything doesn't match that, we ask the user to pick a strategy to deal with that. You can drop it. You can block forever and like fail, and like we will set off an alarm and wake you up in the middle of the night. You don't want that one, trust me. Or the third option is like, you can dead letter queue this, right? We can remove it from the stream. We can park it in another topic for you to examine when you do wake up. If you choose the third option, which is like mostly the right option, we'll sort of capture that for you and give you the tools that you need to inspect that queue. And then you can decide to re-inject that data back into the pipeline effectively as late data, or discard it and just ignore it forever if it's like truly malformed. But, it does break the ordering guarantee, right? Because we're pulling those events out of the stream. And so I don't know of a great fourth option. I'm taking sort of like all pitches on the fourth option, but I think the thing that we can do is create that structure for people and say like, those are your options. These are the guarantees. This is the net result of this. And we can do the same thing sort of, because the streams are internal and the pipelines are off the streams. At that point forward, it actually becomes just type checking all the way through. And so like Decodable will make sure that the pipeline only references fields available in the stream, and the stream only gets data that was valid as produced by the connector. And that goes all the way through to the sync side as well. There's lots of nice things that come from that. One, not at pipeline activation time or job deployment time, but at the time you create that pipeline, we can immediately tell you the stream doesn't have that field or it's the wrong type. You have to do some kind of conversion to be able to use it. And at runtime, we deal with that through this, malformed data strategy that you can attach to different parts of the system. And then we can effectively guarantee that the pipeline never sees malformed data because it can't make it into the stream. So like, that's how we sort of deal with that. The downside, of course, is that like, there's a whole lot of schema management, right? Like, but I think like the idea that schema management doesn't exist with other systems is at its core the problem. And so we sort of promote that to the forefront and say like, look, you just can't do it. There are things I think we can do going forward to make that process even easier, including things like coordinated schema changes. For instance, I want to add a new field from the connector. Let's make sure that doesn't break anything downstream. And like maybe I want to automatically make schema changes to everything downstream. Whether or not that's a good idea, like I think there are different use cases, but I think we want to be able to support what we call safe schema migrations, including things like I want to drop a column. There's actually a safe way to do that involves a multi-step process. We can actually enforce that. We'll let the user opt out of that. Don't get me wrong. If you really want to, be a sociopath and delete a column and break everybody downstream of you, like we're happy to let you do that. But, there is a right way of doing that. And so we can put quite a bit of stuff around that. And then, of course, we have all this access to metadata. We can actually do lineage analysis in a streaming context. We can do data quality measurements and sort of, all the stuff that you would expect with excellent batch systems like, I think Monte Carlo and Great Expectations and like all these other kinds of things that data engineers sort of know and love, the techniques are equally viable in a streaming context, although the implementation does look a little different.
A couple other directions I want to go from there. So one of the things you mentioned is sort of the deployment of the jobs. I'm wondering if you can talk through some of the sort of software lifecycle of building the pipelines, validating them, rolling them out, and sort of what that overall workflow looks like with Decodable.
Yeah, absolutely. So we version all of the pipelines internally. We basically have like CRUD style operations. You can create, you can view, you can delete, you can update your pipelines. But we've added an activate and deactivate process. And so as you update your pipeline, that pipeline doesn't actually get deployed until you tell us to activate it, at which point we will effectively roll over onto the new version of the pipeline. And because we've implemented the engine to be exactly once by default, we effectively, I don't even think we expose the processing guarantees other than exactly once, to the outside world, because that's what most users want anyway. But we will actually checkpoint and sort of save the system. The process for the user is we offer a real-time preview function where you can actually give us a chunk of SQL and we can show you like 10 records of output to help you figure out that like that schema is valid, that you're accessing the right fields, that the data looks the way you expect. And once you get it to that place, which is the equivalent of what you would do in the batch world at like a SQL shell, with Postgres or any of the other database systems, once that query looks the way you want it to, you can then actually tell us that like this should actually be the version of the pipeline. And then you simply tell us to activate that version. And like I said, roll over to that new version of the pipeline. If the pipeline is not backward compatible, that's where you get into like actually like all the really sort of difficult elements of data engineering, where maybe you need to make stream changes, to coincide with that version of the pipeline and things like that. And there, we maintain, version relationships to different streams and stuff like that. And we can actually stop you from making changes that would break other pipelines and other connections and things like that. So it's just a little bit of additional work there. But the big thing I think for users is when you, from our command line or our API, you say like, here's a new chunk of SQL, save this as the pipeline. It's at that point that we will tell you this pipeline's not valid, your SQL's not valid, you're missing fields, they're the wrong data types, all these other kinds of things. So we effectively won't let you save a pipeline that won't run. And so this means that at any time, if there's some kind of failure, or the power goes out and we restart a bunch of nodes, we know we're always restarting from a well-known and good place. And then, of course, people version control their pipelines and stuff like that. But, we have sort of the next level of protection there. The preview feature on a pipeline works by attaching to the actual streams. So it's not like fictitious data. You're actually seeing real world data passing through the pipeline, assuming you have access to do so. And we have found that people very quickly figure out that they're seeing more nulls than they expect, or, the dates aren't parsing quite the right way or something like that. And so I think that kind of iterative ability to inspect not just the schema of the output, but the actual data on the output eliminates quite a bit of challenge there. And in the streaming world, that's just much harder to do than in the batch world. Normally, that wouldn't be a fancy feature, but it is a slightly fancier feature in the streaming world.
Struggling with broken pipelines, stale dashboards, missing data? If this resonates with you, you're not alone. Data engineers struggling with unreliable data need look no further than Monte Carlo, the world's first end-to-end, fully automated data observability platform. In the same way that application performance monitoring ensures reliable software and keeps application downtime at bay, Monte Carlo solves the costly problem of broken data pipelines. Monte Carlo monitors and alerts for data issues across your data warehouses, data lakes, ETL, and business intelligence, reducing the time to detection and resolution from weeks or days to just minutes. Start trusting your data with Monte Carlo today. Visit dataengineeringpodcast.com/impact today to save your spot at Impact, the Data Observability Summit, a half-day virtual event featuring the first U.S. Chief Data Scientist, the founder of the Data Mesh, the creator of Apache Airflow, and more data pioneers spearheading some of the biggest movements in data. The first 50 people who RSVP will be entered to win an Oculus Quest 2. Another interesting topic that's worth digging into is the question of the sort of lineage calculation and metadata propagation and how you're able to pull and push that into the other systems that people are building and relying on and the context within which Decodable is operating to be able to complete that overall metadata graph beyond the confines of your platform.
Yeah, I mean, this is a place where, transparently, we haven't propagated it beyond our platform just yet, right? So we have that information. We can read it from certain external systems, again, like, schema registries and those kinds of things. But we don't yet have a good way of completing the larger graph. And I think part of the problem here is there aren't good standards for how you expose metadata information beyond like the SQL information schema, which is, not as rich as you would like it to be, especially across systems. So I think we're still thinking about different ways that we can make that externally useful so that the schema of the output of a particular job in Decodable is guaranteed to match the schema of a snowflake table. You know what I mean? Like being able to fully extend it there. Now, that said, because we can guarantee that the output of a pipeline schematically matches that of a stream, the output stream, which is attached to a connector, and that schema has to be at least compatible, like a subset. If that connection is actually to a relational database system or something like that that does have a well-defined schema, we actually do have the opportunity to validate it. I don't know how we would visualize that and expose that. My guess is that there's another company being funded someplace in the valley right now to do that and to sort of take on the larger burden there.
Several, in fact.
Yeah. My hope is that all of these data catalog companies that have popped up around things like Open Lineage, and I can't think of the one that came out of LinkedIn and the one that came out of Lyft, the two different data catalogs that neither one of which I can remember. My guess is that like there's a role to do with like integration with those kinds of systems to help people, manage this in the large across products.
Absolutely. Yeah. Data Hub is the one from LinkedIn, and Amundsen is the one from Lyft.
That's it.
The Open Lineage specification is definitely exciting to see, and there's another effort that started up recently called Open Metadata, and it seems that, at least for now, the two are relatively disjoint, where Open Metadata doesn't cover lineage, and Open Lineage doesn't cover more sort of generic metadata. So it'll be interesting to see sort of if they merge or if they decide to expand to conflict with the others. And the classic problem of I have 5 competing standards and I created a new one and now there are 6.
Coming most recently, prior to starting Decodable, having spent some number of years at Splunk and looking at the observability space, this problem exists no matter where you look. Vendors are always and customers are always trying to sort of tackle the proliferation of standards, and hopefully one gains enough steam. But I think that that's really exciting.
In your efforts of building the Decodable platform and determining what the sort of useful APIs and abstractions are, what are some of the most complex or time-consuming engineering challenges that you've dealt with to date?
Our internal mission is to build software that just works. And so all of the stuff that we were talking about earlier around challenges around the complexities of the engines and the messaging guarantees and state management, we spend an undue amount of time, working on those kinds of problems and making sure that performance is above board and, throughput looks the way that it should, for all the different measures of performance. But I think we've also spent a ton of time on the developer experience, right? Just because it's APIs, just because it's a command line tool doesn't mean that there isn't like actually a UX component to this. And the systems I have seen over the 20 something years I've been doing this, be the most successful, it's not strictly about being just simple or being just powerful. It's nailing the intersection of easy things are easy, hard things are possible. Like that sort of adage actually has to be true. And the functionality needs to be really easy to discover and access for, or 100% of people who need it. So I think we agonize over what we call things, over what pieces of metadata exist and those kinds of things, so that when you look at a pipeline or a stream or a connection, it's just like super intuitive what that thing is and how it works and, the functionality that lives there. And so I think that's something that we think quite a bit about. Transparently, we are still early in our journey toward thinking about the right way to expose performance metrics and observability of the pipelines themselves, not necessarily the infrastructure, but, do we actually need to provide sort of all the way down to field level statistics around data quality and, value distributions and those kinds of things in order for people to be successful, or at the other end of the spectrum, is it really just bytes in, bytes out, events in, events out? Is that actually useful? But I got to tell you, not a day goes by that we don't have some conversation about some new failure mode that we have sort of discovered that is possible and sort of work to seal that up. We're at a point now where I feel really confident around, when we say that a SQL statement is good, it's good. And we're able to run it without failures, without issues and things like that, which, sounds like a low bar, but it turns out not to be in the streaming context. So I think those are some of the places where we spend an awful lot of time, but it's really about guarantees and correctness.
In your experience of building Decodable and working with design partners and early customers, what are some of the things that you've learned about the overall state of data engineering and some of the costs and benefits of working with real-time systems?
Yeah, this has been sort of really interesting. I was blown away by the simplicity of the pipelines and sort of how people spent their time. We have seen pipelines that are effectively select a subset of columns from a source and then filtered by one or two fields that adds a mountain of value for the ML engineers and the training data sets and things like that sit on the other side of that pipeline. And so what we found is the issue here isn't necessarily that people are running a small number of these really big, really complex pipelines, which is actually true in the observability space, right? You have logs, you have metrics, you have traces. You've basically got 3 data sets and they are mammoth, and they operate in petabytes per day. And there's a different set of challenges around that. But in this case, we actually find that the complexity comes from customers having literally hundreds or thousands of pipelines that all do slightly different things for slightly different audiences, and maintaining operations around each one of those pipelines. And each of them actually winds up being really simple, right? They're typically these, small, simple SQL statements. And so giving people a system that lets them operate quickly over a large number of pipelines, is something that I don't know that I fully expected, just sort of that complexity and everything that goes along with it. I think the other thing is with respect to real-time data, what we found is that for people who are just ingesting data into analytic systems, I'll level with you. I think they're well, batch is good enough. That's where I hear that argument. For people who are building these event-driven services, various microservices that either produce to Kafka or consume from Kafka, and I say Kafka, but, GCP, PubSub, Kinesis, whatever. That's where those people sort of need real time. There isn't a lot of debate about that. The business basically doesn't work without that being real time. The joke I've made is imagine if Lyft or Uber used batch processes for driver dispatch. You order a Lyft, it shows up 3 days later, because the batch was delayed. That business doesn't work. And I think logistics, retail, oil and gas, gaming, all of these kinds of products and industries have real-time components to them these days. DoorDash, food delivery doesn't work unless it's a real-time system. So I think that, the applications are going that way. I think the analytic systems are going to wind up having to catch up to the operational systems. But the operational side of the house is very quickly going full real-time, if it isn't already.
In your experience of working with your design partners and seeing how they're building on top of Decodable, what are some of the most interesting or innovative or unexpected ways that you've seen it used?
I mean, most of the use cases we've seen have actually been about what we expected. It's data prep, it's streaming ETL. There's some folks looking at sort of aggregation and real-time analytics and things like building and populating feature stores, for ML pipelines. There they want to, roll things up into aggregate counts and those kinds of things. But for the most part, I think the products are innovative, but the use of real-time streaming is I don't want to say mundane, but, it was needlessly complex. I think it was super exciting before they started using Decodable because they had this crazy Rube Goldberg machine of things that were all stitched together. But, these days, I think it's actually less exciting. And that to me is what success actually looks like, is that it's becoming a boring problem, right? Can we make it a boring problem? I think that that's what success looks like for us. So we're excited by that.
On average, I'm curious how many different sort of infrastructure and system components you've seen people replacing with Decodable.
We've seen people shut down, effectively the triplet of, this is probably not fair, but we've taken on the stream processing engine and to some degree parts of the messaging system. But realistically, it's actually our job to stitch those systems together for you. And so for people who have something like Kafka, in place, simply to facilitate the data integration and the event-driven architecture backend, we see that get subsumed by Decodable. For people who use Kafka as effectively a part of their system, then I think it makes sense for people to continue to run that stuff. So I don't know that we compete. I would never say that we compete with Kafka or, any other sort of messaging system and things like that. We have seen people shut down complex streaming, do-it-yourself streaming systems and those kinds of things. So I think there and a whole lot of operational infrastructure built around those systems to deploy pipelines safely or perform data quality checking and all these other kinds of things. So I think it's really in sort of simplifying the operational side of the house in a lot of ways by giving them a turnkey system for this.
In your own experience of building the platform and going through the engineering and working with your customers, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think as an engineer, I've always wanted to believe that the pipeline's the hard part, and it's just not. It's the operations. And I think, again, in retrospect, this seems obvious. You build a microservice and I deploy it to Kubernetes, life is easy. And it turns out that, using that as an analogy, that's when the hard part starts. Now you have one more thing to monitor, and you've got liveness probes, and you've got observability infrastructure, and you've got security stuff, and you've got key management, role-based access control and namespace management, all that kind of stuff. I think in the data engineering world, the actual act of writing the pipeline is the smallest part of our job. It's the, impact analysis and lineage tracing and sort of operational aspects around schema migration. Oops, we accidentally spilled a whole bunch of PII data into a system that shouldn't have it. And now we need to fix that. I'm not going to name names on, on where I saw that happen, but, those kinds of things are the kinds of things that I think data engineers spend most of their time. And then just context switching between the 5,000 customers that people have, internally and sort of managing all those different use cases. So, in a lot of ways, this is why I sort of emphasized, can we make it just work, and do what it's supposed to do? Because I think, we're not looking to replace or make it easier for people to build the pipeline. We're making it easier for them to run the pipeline, if that makes sense.
Absolutely. Yeah.
But that, I think, surprised me, where the complexity of the problem is. Although, like I said, when I look back at it, I feel naive believing that, the problem was anything but that.
Yeah. Speaking as somebody who spends a lot of time in operations and infrastructure engineering, I can definitely concur that, writing the thing is, well, it has its challenges. That's the easy part. And then you actually have to be able to run it. And that's why I always get frustrated when I look at these, demo applications of like, oh, this is how you wire these things together. Or, oh, this is how you get this thing running in Kubernetes. It's like, okay, it's running technically, yes, but that's nowhere near complete. Now I need to add these 15 other systems and manage how do I get the credentials into there without, exposing them. And yeah, absolutely.
Yeah. And especially in the data world, as concerns around privacy and governance come, to the fore, there's like a whole nother aspect of like operational complexity that comes, as it should, right? Somebody shows up and says like, show me all the places you're using email address. Like, how do you even answer that question? I mean, like, some people have the right infrastructure to answer that question, but like those kinds of things become really, really complicated. I'm with you. I think that, hello world is where things start, not where they end, if that makes sense.
And so for people who are interested in being able to build streaming pipelines and real-time systems, or they already have some of that infrastructure in place and they want to simplify, what are the cases where Decodable is the wrong choice?
So I don't think we are a system of record for like storing data. I actually don't think that using messaging topics as like persistent databases is like the right sort of thing to do. And so we don't view ourselves as the data warehouse. We don't view ourselves as an analytic system. I actually think that even in the streaming space, we aren't like a streaming data warehouse. We don't sort of pitch ourselves that way. Instead, I think that if you need to like collect a whole bunch of data, turn it into a different kind of data and like send it someplace, we are definitely the right system. We call it data engineering now, but in my day, we used to call that ETL. But don't tell anybody I said that. I think we are sort of data janitors. We're definitely not like an ML system, although we feed those systems. So we're not going to be like operationalizing ML pipelines and stuff like that. On the other hand, if you need to pump data into, there's a bunch of like really sophisticated ML ops kind of systems that handle like model training and, model deployment, basically do all the same stuff, but for models. I think we complement those kinds of systems. And I don't necessarily think we're a general purpose like messaging replacement. We're not just like Flink as a service or a Kafka replacement. There are plenty of people sort of working on those problems. We view those things as things that we work with, not things that we necessarily replace. Now that I've probably talked myself out of a whole bunch of business, I think that said, there's lots of things where, if what people need to do is stand up pipelines, quickly that work and like always work and don't want to manage infrastructure, don't want to deal with, tweaking and tuning all these distributed systems, that's the place where we fit really well.
And as you continue to build out the platform and as you go through your initial public launch, what are some of the things that you have planned for the near to medium term future of Decodable?
We have focused on getting the basics really right, and to the exclusion of fancy features. So when we demo it to people, it's like a SQL statement processing data, and everybody goes, well, is that it? And like, yeah, there's a whole lot there, but I think there's lots of things I think we're going to wind up doing around connectivity to different systems, data observability. I think we are just scratching the surface around helping people to understand impact. Like, can I shut down this pipeline? If I do, who does that impact? I think there's so much there that we can do. And quite a bit of like what I would think of as workflow. The way I pitch it to investors is like, Git works really well. GitHub and GitLab add tons of functionality on top of that to like make it, again, safe for mere mortals, put all the workflow around it, integrate it with all the right systems and things like that. I kind of view that as our relationship to things like Kafka and Flink. We sort of use those systems, but there's a lot of work around, like I said, safe schema migrations, even dealing with like the equivalent of canary deploys for pipelines. We're actually working on some stuff there that I think is really interesting. where you can sort of like a Kubernetes rolling restart. You can basically say, here's my new pipeline. I want to run a shadow version of this, watch the data quality. And if the data quality stays within some bounds, I want to promote that to be the pipeline and have it sort of take over for the old one. So there's lots of, interesting workflow stuff there I think that we can do to make it much, much easier and much safer to build data infrastructure at scale, for companies out there.
Are there any other aspects of what you're building at Decodable or the overall space of building pipelines on streaming systems that we didn't discuss yet that you'd like to cover before we close out the show?
No, just that I think it's a really interesting space. There are a bunch of people doing work to carry real time all the way out to applications with like async API, is sort of like a standard to sort of make that. I think Slack and a bunch of other people are sort of, working on that. I think there's lots of interesting stuff. And I do think that there's going to be a change in how data warehousing and analytics look as the world moves more and more real time. I am excited about what other folks in the space are doing there. Materialize comes to mind. I think it's really exciting. I think it's an interesting space to watch. It's certainly incumbent on us as people who build tools and systems to make these things more accessible, to the general public and just not have so many sharp edges. And, I think we're sort of seeing a streaming renaissance there.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I really think that I don't know necessarily what causes this, but every company under the sun has a data platform team. And I can't help but wonder the collective effort we spend replicating whatever this sort of same set of capabilities is across like the global 2000 and even startups. It does sort of feel like we're doing something wrong and repetitive, especially in the data platform case, right? I think compute platform is really centered around, it was like VMware and then it was like AWS and then it became Kubernetes. Like, is there something that looks a whole lot more prescriptive, but still flexible enough to be the kind of platform that comes not just with technology, but with like an architecture that is like effectively guaranteed to give you what the most tech savvy companies out there already have in place. I don't necessarily know what that is. I do think there's like a data substrate component to that. And quite frankly, that's our vision, is that like there's this, what does the software defined network for data look like? And that's what I think Decodable winds up, growing up into becoming. But I don't know that that's the totality of the story. In fact, I'm positive that's not the totality of the story. So I don't know what that is, but, we certainly have our work cut out for us. That's for sure.
Yeah. Well, if you look at all the blogs that have been coming out recently, it's the quote unquote modern data stack. But I think that that's only the right answer up to a certain point of scale or complexity, where it's the 80% case for I just need to get something up and running. But then when you actually start doing something interesting or specific to your business or organization, then it is no longer the complete solution.
Right. So, not just something that scales up to, like Google scale or Facebook scale or something like that, but something that scales down in resource cost and complexity, something that can easily be deployed by a 3-person startup and then sort of grow with them. MySQL and Postgres are actually really good at this. I don't know what that looks like for the rest of the data platform. I think we have a lot of work to do to figure that out.
Well, thank you very much for taking the time today to join me and share the work that you're doing at Decodable. It's definitely a very interesting platform and an interesting project, and solving a very real need for people who have banged their heads against the semantics of streaming systems and distributed systems and real-time guarantees. So appreciate all of the time and effort you and your team are putting into that, and I hope you enjoy the rest of your day.
Thank you so much. It was a real pleasure.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.